All right. Welcome to the session on 12 ways to make code suck less. My name is Venkat Subramaniam. I want to talk about some of the ways we can improve code quality. Code quality is something that's very near and dear to me. We all spend a lot of time reading code. So what can we do to really make our lives a lot easier? But I'm also a why kind of a guy. I always want to ask why. So I want to first start with the question, why should we really make the code quality better? And I think the answer I can think about is that really, we are in a world where everybody wants to be agile, but I want to emphasize that we cannot be agile if our code sucks. As simple as that. When you're sitting down in a meeting, somebody is suggesting that they want to make an enhancement or a change to a particular part of the system, and then you realize, wait a minute, they're talking about this XYZ module, and the last time I touched that, I could not go home for the weekend. You're going to convince them this is not a good change to make. So it's incredibly difficult to be agile if the code we are writing really is of poor quality. So if you want to really maintain sustainable development, we have to really aim for good quality of code. But then, of course, how do you tell that the code is good quality? Well, the code we write actually has a deep meaning. Code is how we tell our colleagues how we feel about them. So when you're looking at a piece of code, that's what they have left behind for you to read. And how do they feel about you when they write the code? Do they say we love you when they write the code? Or do they hate you when they write the code? So the code that you're reading, usually tells you that. And that's one of the reasons why it's important for us to really focus on good quality of code that we are writing. That becomes very critical. And it turns out that lowering quality of code really lengthens the development time. That's the first law of programming. So if you want to really go slow, create poor quality code, and that slows you down naturally. So it's important for us to really focus on good quality code for that reason. But how do you really say a code is of good quality? How do you measure it? Well, it's really qualitative, but one measure I would use is the following. The quality of code is inversely proportional to the effort it takes to understand it. So if I'm spending more time on a piece of code, that usually is poor quality. If I'm spending a lot less time getting it and moving on from the code, then usually I would argue that it's actually a better quality code. So I want to be spending as little time as possible to grasp and understand a piece of code. That becomes extremely critical. So I want to talk about 12 ways in which we can improve the quality of code we are writing. So let's start with a countdown. The first way to improve the quality of code is to really tackle the technical debt. Now, I work with a lot of different teams around the world, so when I go to a team, I always look around and see if they have identified their technical debt. And you'd be surprised how many teams don't have a clue what their real technical debt is. If you're trying to help somebody, well, the term technical debt was coined by Ward Cunningham, and he coined this as part of his work in the financial industry. And technical debt has a lot of relationship to, like how financial debt is. If you have somebody, a friend maybe, or a family member who has financial problems, what do you normally do? The first question you ask them is, what's your debt? If they don't even have a clue what their debt is, that's even more trouble. And then once you identify what their debt is, what do? You list the debts down, and then you take the highest paying interest one and work your way down. Well, that's exactly on software projects. I would like to know, do you know what your technical debts are? And if we don't know what our technical debt is, we have to identify that. Now, if you don't really solve financial debt, what happens? Well, I charge an amount of money. The credit card company sends me a bill at the end of the month saying, I only need to pay a minimum balance. This sounds interesting. So I send a minimum amount, and I keep charging. At the end of the year, I've exceeded my credit limit. So what does the bank do? They send me a letter saying I've exceeded my credit limit. But then the bank says, you're an important customer. So they increase my credit limit. Well, the reason is the bank never wants me to get into trouble. They want me to get into real trouble. So I keep charging, and at some point, the amount I owe is more than a yearly salary. So what do I do now? Well, I got to declare financial bankruptcy, or maybe I should change my name, grow a beard, and move to another state. Just for the sake of records, that's not the reason I left Texas. So the point really is we simply cannot really handle this kind of a situation, and we get into financial crisis. Well, a lot of projects do this. They get into a technical bankruptcy, and where nobody ever wants to touch the code. You probably have seen these projects. Everybody is leaving, and nobody wants to be hired on this project. And that becomes really hard to maintain code after that. So we need to really understand what the technical debt is. So what are technical debt? Oh, that schema, we haven't really upgraded for a while. It's kind of bent out of shape. We need to revisit it. Oh, those methods that's been deprecated for a while, but we haven't had time to really upgrade those methods to non-deprecated methods. And a lot of these things, this library has been really not performing. We don't have time really to go fix it. But what is not a technical debt? Lowering quality intentionally is not a technical debt. We got to be very careful about it. That's called sabotage. So we have to really focus on handling the proper technical debt along the way, and we got to pay it accordingly. But what causes technical debt? Well, a lot of times our schedule pressure causes technical debt. And that's one of the reasons I want to emphasize. When you're in a sprint planning, don't commit all your time to do actual work on the project for new development and fixing bugs. Schedule some time for paying the technical debt. It is not an all or nothing. You can't say, I can't pay everything, so I'm not going to pay nothing. Doesn't really help. So what you really want to do is you want to schedule a time. So you schedule a certain amount of time for development, but you also schedule time for other activities like planning, for example. And of course, there's time for taking vacations or people falling sick. But you also have to take some time for paying the technical debt. That becomes very important. So one of the things I say on projects is every sprint, ask your organization, do you know, first of all, what your technical debt is? And second, what are you going to do about it? Can we schedule maybe 10%, maybe 15% of the time where we're not going to be doing work on developing new code or fixing those bugs, but just revisiting and reworking some of these technical debt and clearing them along the way. And unless we take a very active role in scheduling time for it, it's not going to go away. But not only do we want to schedule time to pay technical debt, there's another very important thing we need to really keep in mind. A person I really admire a lot is Linda Rising. And she wrote really good books. And one of the things she told once really stuck to me. She said, a freeway which is packed with cars is a parking lot. And that is so important to keep in mind. If you pack a freeway with cars, it turns into a parking lot, nothing moves around. Well, that's exactly what your schedule is. If you schedule every minute of your day to do work, you don't have any slack time. And if you don't have slack time, you will never be able to innovate. And that becomes really a problem. As individual and as organization, it's extremely important to have slack time. This is a lesson I've taken to heart myself. I'm trying to really reduce what I do and have some free time so I can just take a breather and think about other things I can do and improve what I do also. So one of the books I really like a lot is this book called Guns, Germs, and Steel. And in this book, he talks about the history of the civilization. And it's very fascinating when you read this. He talks about how people were savages. There are some people still savages, but mostly we have civilized. And he says when people were savages, they had to get up in the morning and they had to go hunt for food. And when you have to get every day, you got to get up and hunt for food. And if you don't hunt for food, you starve. So you have to always be on the run hunting for food. And then he says people figured out they could do agriculture. You could grow things. And they found out they could domesticate animals. How cool that is. You could entice a little lamb and keep it with you, and when you're ready to eat, you can just kill it and eat it. This is awesome, right? So once they started doing it, they realized, I don't have to go hunting today. I could take the day off. What are you going to do, Johnny, with the day off? Well, maybe I can create art. I can, create songs. Well, culture started developing when people had slack time. And that's one of the things we have to really keep in mind. As organizations, we tend to forget this, and we just put people to work to death. And that really does not help us at all in getting better at what we do. So we have to really start putting those slack times in, and also schedule times to pay technical debt. Also, that becomes extremely important. Well, the second thing I want to talk about here is to maintain code with high cohesion. So what is cohesion? Cohesion is where like things are together and unlike things are apart. So you don't want to put code where everything is mixed up. You don't want to put code where, let me ask the question, and raise your hand if you think putting business logic in the GUI is a good idea. Not a single person raised the hand. Let me ask you a different question. Raise your hand if you see business logic in the GUI. Right? So notice the hands going up. This is called cognitive dissonance, right? I know nobody here is doing it. Somebody else is doing it. But the point really is, that's really a bad idea. That's lack of cohesion. But the question is why? Why should we not really put things together? Well, the reason really is that it really reduces the frequency of change. You are going to change the software. There's absolutely, you cannot save a software from being, changed. If somebody comes to you and says, I wrote this software but never changed it, what they're telling you is their project got canceled. If anybody is working on any relevant project, we have to change it. But you don't want to change the software by changing every piece of code. That's very expensive. So you want to release the next version, the change, by minimizing the change through. A cohesive application reduces the change we have to do. That's one of the reasons we want to really reduce to increase cohesion. So cohesion is where like things are together and unlike things are apart, and you want to really keep like things together, and that's where we modularize things. We ask, what is it really this code is doing? And anything that's not relevant to it, move it away into another piece of code. This also reflects back on cyclomatic complexity of code as well. Longer methods really are not very cohesive and cause a lot of problems, for example. Well, in addition to cohesion, we also want to keep an eye on coupling. Well, oftentimes people talk about lowering coupling. Well, you cannot eliminate coupling all the time, but you want to be able to minimize the coupling as much as you can, but you want to do loose coupling where it's possible. Well, tight coupling makes extending code really, really hard. So you want to reduce coupling as much as you can. But I'm actually a bigger fan of not just reducing coupling, but actually eliminating coupling where we can. Reminds me of an experience. I was in a conference where it was an open space conference, and people were talking about how they really like testing, but they find mock objects to be unbearable. And as I was listening to them, after a few minutes of listening to them, I blurted out saying, hey folks, maybe you're having a really hard time testing your software, maybe because your design sucks. And by saying it, I made everyone in the room angry. And they all looked at me and said, who are you? Why would you tell us our design is bad? Well, I said, I create a lot of bad design. I thought you guys are like me. Well, we then started talking about why mocking becomes an issue. And then we quickly realized the problem in this case is that we have dependencies that we have taken in face value. We've assumed that these dependencies are there and they are going to stay. And a lot of times these are accidental dependencies. So here's an example. The code on the very far left is using the code on the middle, and the code on the middle is using the one on the right side. But the one on the right side is very non-predictable. It's kind of like maybe a code that tells us what the weather is. Now, this causes a really big problem because the code in the middle is really hard to test. It's also really hard to extend as well. Well, but if you're going to write a test on it, every single test may have to mark out the code on the right side. If people do this, they get into this wonderful world I call as mocking hell. And mocking hell is not a very nice place to be in after all. And it becomes really painful to write code and write test. But this is where I suggest that we should eliminate dependency. So what I want to do is I want to move the dependency or eliminate it from the middle code and move it up to the one on the left. Now, when I do this, the beauty of this is I can pass a piece of data to the code on the right, and then that can use the code. I have to do almost no mocking for this code. Well, that code, which was doing quite a bit of complex work, now becomes a lot easier to test. It doesn't have this dependency. Well, sure enough, the code on the left now took on a dependency that it did not have before. But the beauty of this is it requires actually a lot less testing than the other pieces of code did. And so we can actually reduce the burden on ourselves in these cases. So by eliminating or at least moving away dependencies, we can save quite a bit of effort. I apply this technique quite often when I write code. And this generally actually makes our life a lot easier and reduces the mocking also that we would need. Well, the next thing I want to emphasize here is when we write code, we want to program with intention. I'm sure you've seen your share, right? You're staring at a piece of code, and you're not sure why that code actually works. And you're looking at it like, this is not supposed to work, but it works. And you're scratching your head, and you're not sure why, and it's very frustrating. And somebody suggests to you to make a little change, and it works, and now it's even more frustrating when it doesn't work in the first place. These kinds of code are very, very tricky. So how can we really get better at it? Well, I came across this particular phrase that just sums it up. It said, well, when I wrote this code, only God and I understood what I was doing. Now God only knows. We all have this feeling sometimes, right? You look at this code and you start complaining endlessly about this code. Sometimes you complain so much about a code, right? And then you realize, scrolling up, it's your name on the top. It doesn't feel that bad anymore, right? And you think to yourself, there's got to be a reason I wrote this. Very frustrating when you come across code like this. It can be really hard to maintain over time. So I'm a huge fan of this rule called the Ken Beck's rule of simple design. And he emphasizes 4 simple rules to create better quality code. He says that code has to pass all tests. The very first statement has an implicit assumption there that we actually have tests. So the code passes all tests. But the second thing he talks about is the code reveals its intentions. And that is very important emphasis. The code should be really expressive. It should be easy to see through what we call as a transparent code versus an opaque code. And then he says that it should reveal its intentions, should be obvious what it's trying to do, should have no duplications, and should be very minimalistic. I'm a huge fan of this last point about minimalistic code, minimalistic design, and I go maybe sometimes overboard in keeping things really minimum because I don't want to really get into a lot of messy code. The less code I have, the fewer bugs I have. The less code I have, the less I have to maintain when I have to make a change to the code. So in a lot of different ways, it can really help us a great deal. But one of the best ways I've figured out to write code with intention is to write a test before writing the code. Because if you're writing a test, you're going to sit there and think about what should this code do before you actually sit down to write the code. So it forces you to not only think about the code you're going to write, but also how somebody would be using this code. And that can help us to really put the intentions into place. So I normally like to write tests before I write code just to bring that out a lot better. So we talked about a few principles, making it really highly cohesive, lowering coupling, programming with intention, scheduling time to lower technical debt. But one of the problems we all face as programmers is this thing called primitive obsession. Primitive obsession is where we feel we have to write the code at the lowest level possible. I was reviewing a code last week, and I had about 10 lines of code. I'm not kidding, 10 lines of code. I'm reading this code back and forth, trying to figure out what this code is doing. And after a few minutes of reading through it, it dawned on me, this code is doing something that's already in the JDK. So I commented the code out, made one call to a JDK function, and all the tests are still passing. I quietly checked in the code, didn't say a word for the programmer to discover this and remove it. We do this. Sometimes we step into a code and think about this and say, I've got to write this code. And then you spend all the time writing it, and you feel really accomplished. That was a very hard day at work. And then you realize all that is already done. We just wasted time doing this. But there are other places where this gets very tricky also. So I'm going to say imperative code is packed with accidental complexity. This is one of the saddest part. Most of us have been programming with imperative style code for about 20 years or more, which means we have been programming with something which is inherently more complex. The functional code is very unfamiliar to most of us, but it turns out it's a lot simpler. It removes accidental complexity. To illustrate the point, I want to take a little example, and I want to play with it right here. So let's take a look at an example here. I've got a little function called isPrime. Don't worry about what it does. It tells you it's prime. And I have a function, a little variable n, which is 101, k, which is 51. But here's what I want to do. Find the total of the square root of the first k prime numbers starting with n. So how do I do this? Well, I'll first say int index equals to n. And then I'll say count is equal to 0. Things are going really well. So double total equal to 0. Notice how we wasted our effort creating variables and doing no real work. These are called garbage variables. We create variables like this all the time. But if you create garbage variables many times, what do? You get angry. So what do? You don't call it index, you call it I. You don't call it count, you call it C. You don't call it total, you call it T. Because you are telling those variables you don't deserve to exist. And then that's how we express our intent, right? So in this case, of course, what am I going to do? While count is less than 0, stop. Is it less than or equal to? Do you ever ask the question? Every single day. And the day you don't ask is called the National Off by One Error Day. And that's really annoying. And then what do? Then you say if, and then isPrime of index. Now that you have 4 variables, you got to stop and think which one. And then what do? Well, if it's a prime number, total plus equal to math.square root of index. And then finally, when you're done with this, I'm going to return, even better, the total. Is this code right? No. What am I missing? Increment the index. Okay, let me increment the index. So index plus plus. Is that good? Are we done? What am I missing? Increment the count. Okay, count plus plus. Is that correct? What's the problem? Do it outside. Isn't that beautiful? You got to think about this. Do I put it here or do I put this here? Is this correct? What is wrong? What about K? So this should be is less than K. Is this correct now? Did you just notice? You all went from saying no to quietness. This is one thing I've noticed. Programmers are the smartest people on earth. Try this at work on Monday. Go to a developer and say, is this code correct? They will never say yes. They'll say, it looks good. Because when you find that it is broken, they'll say, it only looked good. I didn't say yes. So let's go ahead and run this. It looks good, right? So you run the code, and it produced wrong answer after all this. Wow, this loses faith in humanity, isn't it? So that is obviously wrong. I made a mistake, right? You know, you could be still working on this code, trying to find out why it doesn't work, but I got something for you. How does this code make you feel? Really stupid, isn't it? In fact, I have a theory. It's code like this that prematurely makes programmers into managers. Right? You're like, I'm done. You clowns sit there and work on this. I'm done, right? This is an example where it gets really bad. We don't want to do that. So what can we do differently? Maybe we can try this. Maybe there is hope for us. So what I'm going to do is retry this. And I'm going to say stream, well, return, of course, stream.iterator. Well, where am I going to start? N, E, and E plus 1. Hey, what in the world is that? That's an infinite stream. Wow, how long is the infinite stream? Duh, it's infinite. Well, if it's infinite, where do you store it? On the cloud, of course. Okay, so then what do? I want to say filter, sample in this case, of course, and I'm going to say this is E's prime, great. Then what do I want to do? I want to map, and I'm going to say math square root. Are we done? Well, you got to say limit. Limit what? K. Is it less than K? It's K, damn it, move on, right? And then, of course, I'm going to say sum it and total it and return it. Well, let's see what this code is going to do. Well, in this case, of course, I got to have the stream coming in. So stream.iterate. So I have a stream, iterate, not iterator. Okay, so go ahead and run that code. And you can see that's the answer, not 10. So you can see how that code ended up being a lot better than what we tried. So unfortunately, when we write code that is really unmanageable, we normally suffer the consequences of the code. That's what we end up doing. But thankfully, by writing code that is easier to understand, easier to work with, if you look at the code, the imperative style code, if you're showing this code to a colleague or a business analyst, you're sitting and trying to debug this code. Your business analyst says, hey, what does this code do? You say, that's what I'm trying to figure out, be quiet. And this becomes very frustrating. But code like this, you can actually talk to them. You can say, this is what we do. Step 1, step 2, step 3, step 4, does it make sense? You do a single pass through this code. It's easier to understand, as you can see. So a good code should really read like a story, not like a puzzle. So when you write a piece of code that looks like a puzzle, what happens? Everybody is scratching their head, trying to figure out. In the meantime, we have production code to release. But I want a code to be like a story. You just read it, it's like, oh, that was interesting, got it, right? You don't want to have puzzles in the code. It should be really easy to understand it. Well, the beauty of this is we get excited about functional programming, but the real power here is declarative style of programming. So on the left, I have imperative style. On the right, I have declarative style. But it turns out every piece of functional style code is actually declarative. So what is imperative style code? Imperative style code is where you have to say the same thing over and over and over. This is like talking to a toddler. The first day you talk to a toddler, it's exciting. The next day you talk to the toddler, you realize you have to say the same thing. The third day, you got to repeat the same thing again. Walk slowly, please. Don't step on the cat. Hold it with both hands. And then you realize this is going to go on for the next 18 years. This is called parenting, right? The declarative code, on the other hand, you tell what to do, but you don't focus on how to do it. So that becomes a lot easier to work with it. But it turns out functional style code actually is declarative plus higher order functions. So it's the declarative nature of functional style that really gives us the advantage. And so that's one of the reasons why we want to favor that. Thankfully, most of the languages today support that, including Java, of course, so we can start using it. The next one I want to talk about is to avoid clever code and to use clear code. Now, we all have taken time to write clever code, haven't we? Why do we write clever code? Because it feels good. And when you write a clever code, your proverbial hand comes and pats you in the back, right? It's like, you are awesome. Well, I remember this experience. I can never forget it. I got an email saying, something is really off. Can you fix it? And I looked at the problem. I would have fixed it in 5 minutes. I could have fixed it in 5 minutes. But I said to myself, why would I want to fix this problem? I want to fix the mother of all problems. And so I spent an hour coding this. Honestly, when I finished coding it, I had an out-of-body experience. I saw Venkat get up and pat me in the back and hug me and say, you are the most awesome, right? And it felt really good. About, a couple of weeks went by. I got this email from the client saying something really terrible has happened in production. I looked at it, immediately replied saying, don't worry, I can take care of it in the next few minutes. They said, we know you can take care of it, you are good. I replied back saying, no, I can take care of it not because I'm good. I can take care of it because I caused it. And I remembered this, and what did I do? I undid my code and put that 5-minute solution. It's been 7 years now, no problems at all. So these days, when I'm writing code, a thought comes to me that this is clever. I delete the code immediately, and I start over. I don't want to write clever code anymore. I want to write clear code. So that's something we have to really work hard to create code that is actually easier to understand. Well, here's one of the quotes I really like a lot. Programs must be written for people to read and only incidentally for machines to execute. That is something we have to really strive hard because code is written once, but it's rewritten several times. Code is being read several times, so it is our responsibility, professional responsibility, to really make the code readable. That becomes extremely important. Otherwise, we are going to be really causing more expense for the organization. I'm going to say 10% of the time, we write ugly code for performance reasons. The other 90%, we write ugly code just to be consistent with the other pieces of code, so we don't feel guilty about it. And so as a result, the entire code becomes really hard to maintain over time. And those who sacrifice quality to get better performance may actually end up getting neither. And this becomes very evident because when we do realize we have to improve the code is completely beyond repair, and we need a team of people to look at it, and we really fail at it. So another code I really like, there are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies. And the other is to make it so complicated there are no obvious deficiencies. We see this all the time because we don't even know how the code is broken. I remember working with a client, I was looking at this complex code, and suddenly I yelled out saying, oh, wait, I just found a concurrency issue in this code. Here is a variable totally unprotected. Multiple threads could be accessing it. And when I said this, one of the developers got very angry. And the developer said, hey, Venkat, this code has been in production for 3 years. What makes you think you can come and scare us today? I didn't know what to say, but thankfully I didn't have to. Because before I could answer, one of the other developers said, but wait a minute, the code crashes every 3 weeks and we don't know why. So we don't even know why it's failing, and we've been spending a lot of time debugging, so that happens quite often as well. Well, the next one came actually from a totally surprising place. It is a book that I've read before, and I really like this book a lot. It's a very old book, but it's a timeless book. This is a book by William Zinsser on writing well, and he talks about how to write nonfiction. And in writing nonfiction, he outlines 4 principles for writing better English. As I was reading this book, I realized it's not about writing English alone. It directly applies to writing code, I realized. And I've liked this book so much that I've started gifting this to a lot of people these days because it's that good. But the 4 principles he talks about are, the first one is simplicity. So what makes code really, not simple or complex? I'm going to say moving parts make code really complex. If you have a lot of mutability in code, it becomes really complex. So keeping the moving parts fewer and avoiding mutability can help us really make the code simple. It also solving only the real problem we understand and not solving mother of all problems can help us keep the code simple as well. The next thing he talks about is clarity. He says what you write should be clear. That's true for code as well. What makes code really hard to understand? Well, a lot of times the code is hard to understand when the code is not cohesive. When the code has too many things going on, it becomes really hard to understand it. Long functions are hard to understand. A code is not clear when the flow is not really good at all. You're trying to read the code and saying, what are we doing here? Why are we changing this suddenly? Why are we changing this? It becomes really hard to understand it. He talks about brevity. He says shorter, sentences are better than longer sentences. Shorter paragraphs better than longer paragraphs. Shorter chapters better than longer chapters, and so on. Well, in writing code, brevity really comes to keeping the functions smaller, keeping the classes smaller and cohesive, so we can definitely do a lot to address that. But put together, these things are extremely important, that we want to write the code in a way others can understand. And when you write code in a way others can understand, they can maintain the code more effectively by making it clear. One of the other ways to make the code clear is to give good variable names, for example. So if you're giving really poor variable names or class names, it becomes really hard to understand. The last one he mentions is humanity in writing. That was the most difficult for me, because I looked at it and said, humanity? We are programmers. We don't care about that stuff. And I was kind of puzzled by it. And it turned out that's one of the most important things, because when I go to developers and say, how would you program this? They give me all kinds of nonsense. But if I ask them, how would you do this as a human? A beautiful, lively design comes out of things. So I think it's important for us to consider humanity. But I know as programmers, it's really hard. The other day I was at my optometrist. She was looking into my eyes and she asked me, what do you do for a living? I said, I'm a programmer. And then she talked about it for a few minutes and then she suddenly said, what do you do for a living? I said, I'm a programmer. And she said, I know you said it, but I asked you again because you look normal. So, sometimes we feel like this, right? You're not supposed to be, like you are. You should be weird. And that is one of the things we really put humanity as the last. That becomes really hard for us. Oh, this one is really near and dear to me. I refuse to allow comments in my code. I do a lot of code reviews. And when I do code reviews, this is one of the biggest complaints I have about people. I don't like to see comments at all. The reason is I like to see comments that tell me why, not comments that tell us what. I'm sure you have seen your share of really bad comments. The other day I was looking at a piece of code. It said I++, and they were very helpful. They said increment. I'm like, thank you very much. I was not sure. As I'm getting older, I can see these symbols, that's really helpful. Or, comments that, even worse. You got a little variable X, and then they do this. And then there's a beautiful comment that says shift. But I don't know why you shifted. I can see that you shifted it. So this can be extremely painful when we write code. So it's important for us to rethink about commenting in general. So don't comment to cover up bad code. So I am of the opinion that people write comments to cover up bad code. So if somebody tells me, this code is hard to understand, comment it, I'm like, time out. This code is hard to understand, refactor it. So that is something we have to really take the time to make the code readable and understandable. And we want to write code that is expressive and self-documenting. So in my opinion, when it comes to code, I want the code to be self-documenting, expressive. It's easier to see, easier to understand. So to me, a good code is like a good joke. When was the last time you said a joke and people didn't get it? The worst thing you ever do when you tell a joke and people don't get it is start explaining it. It doesn't go well at all. Because you explain it and then they look at you like, is that funny? Why? Let me explain it to you again. It's going to be a very long evening. There's only one right thing to do when you say a joke and people don't get it. You say a joke and people kind of stare at you and you say, never mind. Don't bother. Pretend like I never said that. And then you go home, sit in a corner, think about it, and you refactor your joke. And then the next day you come and try it with a new group of people and see how it goes. And you do it iteratively, improve your jokes. So the point really is, a good joke, good code is like a good joke. Writing comment is like explaining a joke, it never goes well. So when I look at a piece of code, I want to know what the code is doing, what the code is saying. I don't want a stinking comment to come in and tell me what the code is doing. I want the code to be really expressive. This really becomes a problem. We live in a world where we are absolutely infatuated with this, and we make things really worse. I was in Washington, D.C., and I wanted to take a shower, so I got into the shower. I should be showering, but I couldn't. I had to tweet now. Because I saw this and I got very angry. Because the shower had a documentation on it. It says pull to turn on. It's what the heck? Why would I need to be told how to use a shower? So immediately I had to tweet it. Those who cannot design are condemned to document. And we see this all the time. And this becomes incredibly difficult. Our APIs begin to stink. It becomes expensive. People sit there and say, it takes 3 arguments but I don't know which order I should pass them. Why? Because arguments are int p1, int p2, int p3, right? It's like, I don't know which is which, and we waste time trying to figure this out. It becomes expensive over time. Well, here's an order 3. What is 3? I don't know. We'll document it. Well, order 3, large coffee. Well, or maybe we can say order coffee size dot large. Maybe that's a little bit better. The code becomes more expressive. So we can think about creating code in a way it's more expressive so we don't have to be really writing comments as much as we do. So document code using well-chosen meaningful names. Your names become documentation. Use comments to describe the purpose of the code and the constraints. Don't abuse comments to substitute for good code. That is something we should really try to do. We should definitely avoid long methods. Long methods are painful. When we use long methods, it becomes really, really hard to understand what the code is actually doing. There are several problems with long methods. Long methods are hard to understand. Long methods are hard to test. Long methods lead to duplication. Long methods are hard to reuse. The other day I was talking to a gentleman, and he said very painfully, he said, did you notice long methods become longer? It's really true, right? But very sadly true. I travel a lot. So when I go home, one of the things I always say is, looking at my children, I say, oh, you are taller now. That's a good thing. But I come back to work and say, you are longer now. That is not a good thing when you look at the code. So that becomes really painful as well. And when you have long methods lack cohesion. Long methods, increase coupling. It's a diagonally opposite to good design. So good design says high cohesion and low coupling. Long methods have low cohesion and high coupling. So they absolutely are on the opposite end of good design. It becomes really hard to maintain such code. So how long is really long? Well, it turns out this is really a wrong question to ask, because different programming languages have different nature in how we express code. What may be long in one language may not be long in another language. And the number of lines of code is really not a yardstick. So it turns out that the length of the long method really is not about the length of the code, but it's a level of abstraction in the code. So when we look at a method, we should ask, how many levels of abstraction are you dealing with in this code? And we want to really focus on the so-called single level of abstraction. And if a code has a single level of abstraction, that becomes easier to understand, easier to maintain. If a code has several levels of abstraction, it becomes really hard to understand. So one of the things to look at is not the length of the code, but the width of the code. If the code has several levels of indentation, well, it's even worse if they don't indent it, but assume they indent it. Well, that means that it really becomes like a mountain if you look at it on the side. And that can be a problem because to grasp this particular thing, you got to load up so much in your memory. So imagine you are reading a piece of code, and what are you doing? You have to read the code, and then you're like, okay, I got this, and you're reading more, and you got this, and you're reading more. And at some point, you realize, I can't hold all this in my head. If you want to think about what it feels to read long methods, I'll tell you how it feels. You take somebody, and you dunk them in water, and hold them down. After 5 minutes, you let them up, and then again go in. That's how it feels reading long methods, isn't it? Because you're trying to load them all in your mind. You can't just keep up with it. So we have to be really considerate for other people who have to read our code. That becomes extremely important. One of the things that we can do to improve quality of code, and I see this really vexing, because I see this with almost every single developer at various degrees of experience. I work with a lot of clients. I work on projects, so I have to go meet strangers and work with them. And one of the things I get to do as this is to pair up with them. And when I sit with them, I will take note of how they give their variable names. And the variable names are absolutely random. It is kind of like the cat walked on their keyboard to give the variable names. And the other day I was looking at a piece of code, and I did not continue reading the code because now I was trying to find out a pattern in the variable names they were selecting. I wanted to see what the next variable name would be. It's a K and then a Z and a P and a W. What would next one be? So now we are curious to find out this algorithm, if there was one, that they were using to find the variable names. This is really hard. I was teaching a course in Virginia, and I was telling this team they should never use single-letter variable names, other than a few exceptions. One of the developers came to me and he said, hey, we're a Fortune 500 company, we are the biggest software company in the world, and you think you have to come and advise us about writing quality code and not using single-letter variable names. I said, hey, dude, I didn't mean to offend you. If you're doing that, great, awesome, just ignore my comment, move on. He said, oh, I was just pulling your leg. You should come and look at our code. It's a disaster. Everything is a single-letter variables. I said, okay. And then about 6 months later, I was back in the company, and the same guy came to me and he said, do you remember we talked 6 months ago? I said, yeah, I remember you giving me a hard time. He said, I want you to know that you made a difference. So for a minute, I was really proud. I said, really? He said, yes, we don't use single letters anymore. We use only 2 letters now. Habits are really hard to kill. So finding variable names is extremely hard. But one of the reasons is we really have worked with people who have completely ignored us when we did this. I'll give you an example of this. I was walking in the garden with a guy who was way taller than me. He's probably about at least a feet taller than me. I was like a chicken walking next to him. So we were walking. And there was somebody sitting over here, the trash can over there, and he drinks a soft drink or whatever he was drinking, and he throws the can right from here. The can hits the trash can and then falls right on the ground. And the dude who threw it looks at it and says, nah, lost my aim, and then turns on to do something else. So the gentleman I was walking with, this is why it helps to really be tall, I think, he stops and then says, hey, you, do you want to pick it up and put it in the trash can, or do you want me to come and pick you up so you can pick it up and put it in the trash can? And the guy is like, yes, sir, I'll take care of it, and then puts it. I'm like, wow, I want to be like him one day. But this is exactly the point. You see somebody create a bad variable name, you shrug and say, okay, that's life in the big city. But if you say, do you want to create a better variable name, or do you want my help to create a better variable name, you are telling developers, don't come trash my code. We really care about the code we create. And we're not going to let you come and put variable names that don't make any sense, because when you do, it's optimized for writing, but it's totally unoptimized for reading. And everyone else in the team is wasting their time and money trying to figure out what this code is doing, becomes very, very frustrating. So a programmer is somebody who can name their children very quickly, but has a very hard time naming their variables. I remember this experience very well. My wife came to me and said, we want to decide a name for our son or for our kid. Oh, here's the name. She's like, wow, that's it. That's simple, instantaneously a name. I said, sweetie, that's a name for the kid. Now, if you leave me alone, I got to think of the variable name now. And this is really hard for us, right? Because variable names are extremely difficult. Naming children, no problem at all. I can name them more, right? And the point really is it's incredibly difficult to give variable names. I was working on a project for a client, and I was doing code reviews for them, and I was just sitting and pairing with this gentleman as I was doing it, and he just browsed through a piece of code. I said, oh, wait a minute, back up. And then he backs up. I said, would you mind if I take a little photo of this? He said, yeah, go right ahead. It's a very expensive product, and the people working on this code are very expert developers, by the way. And I took a photo, and you may say, what's funny about this code that you took a photo? Well, what I took a photo of was this code. The reason I took code was what was right below this. It said, God help me, I have no idea what this means. and this, when I look at code like this, I have a feeling you are on an expedition, you come down through this cave, and you come to the bottom of the cave, and on the wall, there's a huge written block says, help. And then look down, there's bones below. That's how we feel about it, right? These developers, these were the last words, help. And then they just died away, right? Or quit, one of the two. So these are really hard to maintain. This becomes extremely hard over time. So we have to really think of variable names. Variable names represent abstractions. I don't want to give poor quality variable names. I'm okay with I for an index variable in a loop, that's okay. But in any other case, I want to give names that actually read, tells me what it really means. I know this is a habit, and a lot of us have this habit of just clicking on some keys, 1 or 2 letters, but if we just spend a few minutes thinking about the variable names, it becomes habitual. The good habits become the habit, rather than the bad habits become the habit. So if you cannot name a variable or a function appropriately, it may be a sign that we haven't really understood the true purpose of this variable or function. So this usually is a reflection of us not taking the time to understand deeply what this means, and we have just rushed through it at this point, and that can become really, really hard to maintain. So pausing and asking that question. And this is one of the things, Ken Beck talked about programming with intention. When I write a test and when I write the code, one of the things I emphasize is when you write a test, the first few tests are there to tease out the interface of my class or interface of my function. So I would return silly things from this function. I would return a true or a fake result. And people would look at this and say, that's silly. Why are you writing a test and giving us stupid implementation? Well, they're missing the point. The reason we do this is we take the first few tests to really tease out the functions. Is the function name really good? Or should I change the function name? I don't have to rush to implement the body of the code right now. Let me keep my eyes on the name of the function. Let me think of the parameter types. Let me think of the parameter names. Let me think of the return type. Let me just focus on what this function should do and how it feels for somebody to use it before I come in and start putting the body of the code. And that is the real purpose of writing these tests. If we're not pausing when we are writing these tests, if we use these tests as a mechanical process of just writing something and moving on, then the tests have not really helped us to improve the design of the code. That becomes extremely important for us to use. So it's important to give really good variable names. The next thing I want to emphasize here is to do tactical code reviews. I cannot emphasize the need for code reviews. I started doing code reviews as a young programmer, and this is probably one practice I can tell you that I have followed ever since. There's not been a year when I have not practiced code review on a project. And of course, when I say do code reviews, people get really anxious a lot of times. For example, Joseph says, oh, wait a minute, you guys are going to get together on Thursday afternoon, put my code on the big screen, and then talk bad about me. Oh no, I'm going to call in sick. I'm not going to come to work. Sarah, in the meantime, says, oh, wait a minute, I'm already behind schedule. I don't want to waste my time looking at the stinking code that Joseph wrote. Never mind, I'm not coming for that. In the meantime, the manager comes to you and says, wait, did I hear the word code review? Oh yeah, we're going to do this on Thursday. And the manager says, heck no. Because the last time you guys got together and did a code review, there was a fight, we had to call the cops, and 2 people quit. No more code review for you, right? So code reviews are very politically charged, and nobody likes them. And so as a result, we all shy away from doing it. Well, I've done code review for a few decades now, and if you ask me, this is probably one of the practices that I really, really like a lot. And the reason is, when we do code reviews, we are removing so many errors by proactively reviewing them. So when I do code reviews, I don't not only review code, I actually review the test as well. That's one way to make sure that people are actually writing tests also. In fact, I usually review the test before I review the code itself, so we do a very active code review. We also do what I call as a tactical code review. So what is a tactical code review? We don't bring the entire team into a room to review. Well, I finished a piece of code, and he is going to review it now. Well, the next piece of code I'm writing, he is going to review it. Maybe the third piece of code I'm going to write, he is going to review it. So I'm going to rotate it among the developers. And of course, while he is reviewing my code, his code will be reviewed by another person. So every little piece of code, any task we complete, we got somebody else in the team reviewing it. I'm also not a big fan of using tools. If tools are working for you, that's awesome. If the tools are not working for you, throw them away. The tool is not the issue. Sometimes people tie checking in code to code reviews. I think that's a really terrible idea. Because if you say you cannot check in code if you don't review, people don't check in code. And they delay checking in code, which is not a good thing. Or even worse, they simply approve the code because the check-in can go through. Once in a while, put something absolutely stupid in the code and see if your colleagues are catching it. If they say it's good, you're in trouble. So you want to make sure the code review is actually working. Real feedback has to come. Well, people often ask, how do you motivate a team to really do code review? And I'm not a big fan of mandating things. When they begin to truly feel the benefit of code review, they will come and ask you. I've seen this happen actually. When they come to you and say, would you please review my code because it improves what I'm doing, I'm learning from it, and it only becomes better. And so our code review has to really be valuable, not procedural, not administrative. And when we make it valuable, people will begin to use it. Also keep in mind, you never want to insult people during code reviews. Your goal is never to say, oh, this sucks, or why can't you be a better programmer? These kinds of things are really bad things to say. So my recommendation is never say what's wrong in the code. Always say what can be better. So when you say what can be better, you are giving an escape route for them to apply something or come up with something even better than what you suggested. But this gives an opportunity for them to improve rather than being slapped on their face. Keep in mind that code reviews are both technical and sociological. We have to respect the human who is behind the code as well. That is extremely important for us. So when it comes to this, peer reviews can catch 60% of defects, and perspective-based reviews can be more effective. What I mean by that is the person reviewing the code should be another programmer working with you. I don't want somebody who once used to write the code to come and review the code. Those are called priesthood-based code review. I don't want priesthood-based code review. I want practitioners to be reviewing the code. And peer reviews are complementing to test cases, and we got to keep this aspect of socialness in here. So facilitate this code review, a tactical code review, to improve. The last point I want to bring out here is, if you ask me, there's one thing I've done differently in the past about maybe 5 to 7 years compared to the years before. I always look back and say, what have I done differently in the past few years? Am I just doing the same thing? I can put my finger on this one. I used to create object-oriented code which was bloated, a lot of state. Now when I sit down with developers, they sit down and the first thing they do, they create private variable. I say, why are you creating this variable? I never want the state to be self-serving. I want the state to fall in place to meet the behavior of the code I'm writing. So I never start with private fields and getters and setters. These days I start with methods, write tests for methods, write the methods. But as I'm writing the methods for a certain behavior, certain action, I let the fields come in, the state to fill in, and serve those behavior rather than being self-serving. And this takes a little bit of practice, but once we start doing it, we can move towards minimalism. And I've realized that actually I can create code with a lot fewer state than I used to. And when I also mentor and work with other developers, I often question them, why did we introduce a field right now? Why don't we wait a little bit and see if the field is really needed? Sometimes it is, but a lot of times it's not. So we can reduce the state in the code quite extensively doing this. So reducing state is something very important. So my recommendation is think more, type less, aim for minimalism, fewer states, less mutability, and just enough code for the known relevant parts of the program. Now, this requires us to really focus on reducing and keeping things really minimum. We tend to write a lot of code very quickly. And when we write a lot of code very quickly, remember every line of code we write is a liability for us to maintain. So I'll be very reluctant. In fact, I would say this is what experience really is. You catch a very young programmer who just graduated from school, and at 8:30 in the morning, you stand by the door of the office and say, where are you going? And the programmer, all eager, says, I'm going to go write code. Just wait for 15 years. And the same person, 15 years later, catch them at the door and say, where are you going? I'm going to remove all the code we wrote, right? This is called experience. Experience teaches us to not write code that's not needed, and you're trying to remove it. In fact, sometimes you just come to work enough time to remove whatever somebody else wrote, right? We keep a balance in the system. And so, I work with clients these days, and if you ask me what do, I go to customer side. When I leave, they actually have a lot less code than they did when I came in. It's like, why are we doing all of this? Get rid of it. And we want to really remove this, and mutability makes really hard for us to write code as well. And we want to reduce it. Well, here's my philosophy. Messing with state is the root of many problems, both in software and in politics. A lot of countries go to war because of state. Well, that's exactly what happens when we write code. I was actually looking at a piece of code the other day, and I saw there was enormous amount of mutability in this code. And I noticed this mutability, and I saw a few bugs in the code as well. I just started laughing because the bugs were in the code directly because of this mutability. And I didn't tell the developer, oh, this really is bad, don't do this. I just kind of politely prodded saying, why don't you rewrite this code using this, map and reduce? You don't need this, mutability here. Well, an hour later, the developer comes back to me and says, this is really funny. You told me to refactor this code, so I did. And I was actually shocked because when I removed it, a few errors I had in the code just went away. And that is one of the beautiful things about code is when you reduce mutability, the error rate goes down as well. So I'm going to say mutability needs company. It often hangs around with bugs. They always seen together. They hang out in the bars all together, right? And this happens a lot. So when you reduce mutability, you often have less bugs in code. This is one of the reasons I really like the functional style of programming because we're removing all these garbage variables from code. And that really eases the pain for us quite often. So we want to really reduce that mutability as much as we can. So we talked about the 12 ways to make the code suck. So I want to leave you with some departing thoughts. Well, here's a list of things I talked about. So schedule time to lower technical debt, favor high cohesion, and favor loose coupling. I also want to emphasize when I talk about loose coupling, also reduce coupling as much as you can. Program very deliberately, program with intention, and avoid primitive obsession in code. We tend to really write a lot of code at a very low level, but if we just step back and see, is there a function available already to do this? And think more declaratively than imperatively that can reduce that burden for us. Prefer clear code compared to clever code. If you feel that a code is really clever, rewrite it or ask for help or ask somebody else to read it. If you really want to make a code readable, there's only one way I know to make a code readable, to have somebody read it. So take it to somebody and say, hey, read this code and tell me what you think about it. Apply the principles of writing to writing code. Keep the code simple. Keep the code clear. Keep the code brief. Smaller piece of code is better than longer pieces of code. And consider humanity when writing this code. That becomes extremely important. This is one thing to think about. I was thinking about code and why code is so hard to read. I remember the favorite time, I wanted to really go to graduate school. And so I started reading for GRE. Well, this was back in time. GRE had 3 parts to it: analytical, math, and then English. And I didn't speak English until I was 17. So English is extremely hard for me. And so I looked at this, and I'm like, wow, these English words. Math was not a problem. Analytical was not a problem. I aced both of them, got almost maximum points. And I deliberately failed English because I just could not. I looked at all the words in the GRE. I'm like, my gosh, I thought, people in America speak English that I will never be able to understand. And so I just completely skipped it. The university kind of took pity in me and said, this guy is not really that bad. He can do math. We'll hire him even if he cannot speak. So I went to school, and I was blown away, by the way, because in the 30 years I've lived in the US, not a single day anyone came to me and ever used a word from the GRE book. I can actually understand what they speak. I don't have to look at the dictionary every few minutes. Excuse me, hang on, just hold the thought. I want to see what you're saying. I don't have to look in the dictionary. And then I realized, forget building a wall. The GRE exam does it already, right? It makes it so hard for a lot of people to approach. We have to really be practical in what we offer to people. If people don't have to use those words in the society, why ask them to go through schooling to learn words they would never ever use? Something to think about. So comment why and not what. It's important for us to focus on self-documenting code. That is extremely important. And once we do, the code becomes easier to understand, easier to maintain, and the comments don't go out of sync with the code after all. Avoid long methods, focus on single level of abstraction, and give good meaningful names to variables, and do continuous code reviews, and minimize state and minimize mutability of state as much as you can. So we talked about these about 12 different things, but there's a lot of things we can do almost on a daily basis. And one of the things to remember is the fun is not in writing code. The effort is not in writing code. It is always about rewriting code. And that is something we have to really begin to keep in mind. Because if you look at every single field, even if you look at the greatest of artists who have walked this earth, they never sat down and did things once. Every one of them created prototype after prototype after prototype. And what they created as masterpiece was not the beginning, but a result of a lot of different efforts where they got it. So what we need to keep in mind is one of these departing thoughts. The first step in becoming a better programmer is to let go of the conviction that we can code it once and get it right the first time. Because once we really deeply keep that in mind, we are never in a rush to write the code. We write the code and then we rewrite it, we evolve it, And we then take the pride in actually making the code readable, and then we don't count on how fast I can write the code, but how fast I can help other people read the code. That becomes extremely important. And this is something I remember quite often. When I write books, the latest book I wrote, this is one thing I had to do. I had to throw away completely a chapter 4 times and rewrite it, until the point I started feeling better with it, even before the editors were able to look at it. But knowing that you really have to rework and rewrite gives you the courage, gives you the ability to say, I don't have to just write this once and walk away. I can actually come back and improve my own work. And that, I think, is very noble. If you want to download this code or the slides, it's in the site. I hope you found that useful. That's all I have. Thank you.